Okay, let's talk about binary tree level order traversal 2. So you're given the root of a binary tree. Return the bottom up level order traversal of its node value. So 3, 9, 20, 15, 7, right? You have to return 15, 7, 9, 20, and 3. So this is straightforward for breadth search. So you're adding the queue into, adding the node into a queue, and then for each level, you just add to the list, and then later on you just add to another list. Then when you add to the list of lists, you just have to add to the front. So they just call it. So list integer. I'm gonna call list new linked list. I'm using linked list because that will actually save a lot of time when you add to the front. And if root equal to null, I'm saying return list. So that's the empty list, right? So I need another queue, right? So queue equal to tree null. I'm going to call queue new linked list, and I would just add, go over or add, doesn't matter, add to the queue, and then while queue is not empty, then I will traverse. I will keep looping. Now at the end I just have to return the list, right? Okay. Now I need to store each level node, so I need another list. I'm gonna say a list of integer. I'm gonna call level instead. So this will be, doesn't matter, array list or linked list, it doesn't matter. And what we have to do is we have to memorize the size of the current queue. So in size is actually queue.size, because we need to traverse the full loop. We need the full loop to traverse the current level. And if I at this position, I know my queue, I know my node has 2 children, so I add these 2 children into my queue. So if I just using the queue.size, this is incorrect, because when you pop, right, you do actually modify your size of queue. So this is a fixed size for the level. And tree node, I'm gonna call node, and then queue.pull. So I'm pulling the 3 out, right? I'm adding the 3 and pulling the 3, and I'm gonna check. Okay, so before I check, I'm gonna add to the list of integer, which is level dot add node dot val, and then I'm gonna check if my node dot left is not null, and if it's not null, which means there's a children, right? Then I add my node dot left into the queue. Then same thing for the right, and queue dot add node dot right. Then this will be the solution, but at the end of a for loop, we need to store every single value, which is a list of integer, into the list of lists, right? So we already store every node into the label. Then we need to know, I need to add every single node in this label to the list. So list.add, and I need to add into the front, right? Because the bottom up, right? So 0.label. And for the next level loop, right? You will just keep traversing. Alright, let's just run it. Okay, I do have an error. So what is it? If no, okay, let's see. I made a typo over here. Okay, this pretty good. So standard. And let's think about the time and space complexity. So whatever you do, you need to traverse every single node, right? So that will cost all of n for time. How about the space? Space is all of n because you store every single node into a list of lists, right? That would be all of n, right? So this question is straightforward. You can use breadth search to solve this problem. And then if you have any questions, subscribe, like the video if you want, and then leave a comment if you have any question. Alright, I'll see you next time. Bye.